Hello, everyone. I hope you're having a great KubeCon so far. Today, we are going to discuss something which is about gateways, something about chaos. And the title of our talk is Guardians of the Gateway, Keeping Chaos Out of Your Cloud Highways. We are two speakers. My name is Sayan. I'm a senior software engineer too at Harness. I also maintain the project called Litmus Chaos, which is the chaos engineering open source framework, which we'll see and discuss today. And I'm also an active LFX mentor and a chaos engineering practitioner, of course. And this is my GitHub handle. I'll let Jintao introduce himself.
Thank you, everyone. I'm Jintao, work at Kong, and I'm one of the CNCF ambassador, Microsoft MVP, and Kubernetes ingress and React maintainer.
All right. So we will start today with the discussion on APIs, and we'll see how it affects reliability. So we know that APIs have become the backbone of our software systems, of our modern software systems anyways, right? So they accelerate innovation, they help us scale faster, and they also enable integrations across platforms. So APIs are very crucial, not just for logins or to fetch customer details or user data. They are everywhere. So they are very powerful, but they're also like a double-edged sword. As you can see, they're used in so many different outlets in health, work, travel, transportation, and so on. Now, ideally, not every API is visible or even properly managed. There's a thing called shadow APIs, which are created not in the centralized, but are not in the centralized oversight. So they are increasingly common, and they introduce a lot of risk. And the truth is, every API transaction is critical, whether it's login, payment, or even user data, but they matter because it's not just a function call, it's a potential point of failure. Worse is every API is also an attack vector because the surface area is huge and they basically expose a lot of logic and data that the attackers can exploit. And they don't always go through your traditional firewalls. And to make things even more complex, no two APIs are alike. So they're built by different teams using different protocols. You have REST, you have GraphQL, you have gRPC deployed across different stacks, clouds, regions, and so on. This fragmentation specifically makes governance and controlling them observability incredibly hard. And we are not even keeping up with this because according to Gartner, over 50% of the enterprise APIs will go unmanaged by 2025, towards the end of it. And that's half of all APIs essentially operating without any visibility or control. The business impact is also massive because 81% of orgs reported that just 1 hour of downtime costs over $300,000. And in the last year alone, 50% of those companies experienced an API-related security incident. So yes, APIs are everywhere, and they're not going away. But unless we start managing, observing, and securing them as first-class citizen, we are building our systems on shaky grounds. So yeah, it's a new way, it's a new infrastructure, and it's time we treat it that way. So it brings me to reliability challenges with this. So APIs, like I said, are the glue of the modern architecture because they are reliant on, they are basically what's managing your application across dozens of services. And primarily, one of the reasons of failures is interdependencies, which is cascading failures, basically. So 80% of your cloud-native applications experience downtime due to these interdependent APIs and service failures. And because a lot of them, as we know, 50% are invisible, that means we are at invisible risks as well. So they are undocumented, unmanaged, which makes failure detection even harder. And also, lastly, complexity is definitely everywhere because we have microservices, containers, serverless that leads to a lot of unpredictability in the behavior of when we are talking about hybrid or multi-cloud environments. And yes, as we mentioned, downtime is expensive, and we would want our best to sort of deal with it.
Okay, at Kong, we think for enterprise, the API landscape includes 3 types. One is for internal APIs, another one is for partner APIs, and the last one is the public APIs. For internal APIs, we think every every microservice has its own APIs for internal service, and for partner APIs, we can provide some APIs to our partner. And for example, for B2B service for supply chains, we think the partner APIs during it can public to our partners. We think we need to enhancement the security and the public APIs, because the public API will public to the cloud, and everyone can visit the public APIs. So we think we can enhance the security, and we can add some authorization and authentication for the public APIs. So for Kong, we built a lot of tools for the Kong Connect. For example, we built some tools. For example, Insomnia. We can use Insomnia for API debug, API design, and testing. If anyone used Insomnia, please hands up your hands up. Oh. Okay. Insomnia is a public, is an open source project, and combined the product. We also built some other products. For example, the ingress controller, API gateway, and service mesh. We call all of them as runtime, because every APIs can be served use these products. For example, ingress controller, API gateway, and for now we also created a new project named AI Gateway. And for the connect the platform, we can do some tasks. For example, API government, and API register, and API observability. We can use a lot of plugins to enhancement the API security, and we can integration with a lot of other services. For example, we can integration with OIDC or Okta, and also we built some observability tools. We can integration with Prometheus and OpenTelemetry, and also we can use a unified control plane to add or edit or delete the APIs. And for the on the top, we have the platform application, and we build some product, for example, API products, and we can use these products to analyze our APIs. We can know the status code. We can count the API calls. Also, we think in Kubernetes cluster. The architecture is similar to this one. The client send a request to the gateway, and the gateway forwards the request to the backend services. But sometimes we use HPA or VPA to our application, but we don't expand the gateway. So the gateway is a single node. So I think we think this needs improvement. So we built another product named call operator. The call operator can. The call operator can can create the call gateway. You can use the call operator to deploy call gateway. And the call operator can integration with the Connect, and it has some features. For example, it can do elastic scaling, and it can know scaling based on the CPU or latency. Yeah, but we know the Kong gateway operator is very important, and we use the Kong gateway operator to manage our own gateway instance. So it's a very important project. So we need to build a very stable product.
And we believe that Litmus Chaos can help with this integration to make Kong Gateway Operator more secure. So Litmus is an open source project which I'll describe in a minute. But before we even jump into Litmus, let me talk about chaos engineering, the concept, the principle, so that we have a more clearer idea of what we are heading into. So we'll start with what is chaos engineering. Now this is a simple definition, but I'll explain it in a different way. So imagine simulating an outage just for the sake of being prepared when an actual outage happens. So that, in essence, is the practice of chaos engineering. What we do is we simulate different patterns and behaviors that we observe in the real world when we have an outage. And with the fire drills, with the different events that have occurred, we make our system so resilient that when the actual outage happens, we are much more prepared. So it's a better safe than sorry situation. These are primarily some of the principles that were first advocated by Netflix and then has been expanded on. So we start with the first thing, which is we select the systems that we want to test. Once we have identified the systems, we simulate the chaos experiments. For example, one of the scenarios could be you are simulating an entire region goes down. One of them could be you're injecting latency. Some of them could be your memory or resource hogging, and so on. Once we have identified which experiments we want, we then put specific faults, combine them in certain scenarios to make our hypothesis. Then we run the set of experiments on the targeted system. In this case, we can target the Kong gateway operator or any other dependencies that were a part of it so that we can ensure the reliability of it. Fourthly, we observe the result of the experiments on the targeted system because that's essential so that we can understand what to change, what not to change, how resilient our system is. And lastly, we use those learnings to make the targeted reliability improvements. Now, we introduced Litmus Chaos, which is the open source toolwork or framework. So basically, it's a Kubernetes native open source chaos engineering toolset built for the cloud native infrastructure. It's also community driven and is constantly evolving with a lot of contributions and active maintainers. It also supports multi-cloud chaos support. So for example, you can install or have Litmus in one Kubernetes host and target a lot of other vendors, irrespective of where they are. You can also target bare metals, VMs, specific applications, and so on. And lastly, it's user-friendly because it has its own GUI, and it also has a headless API, so you can integrate it however you wish to. This is typically one way of how the Litmus Chaos framework works. There's a full-fledged architecture diagram, which we can discuss tomorrow on another maintainer track, but just to give an overview of how it works. So we have three main CRDs, which are the Litmus experiment, the Litmus chaos experiment, chaos engine, and the chaos result. And our primary thing is the chaos operator, which is holding everything together, doing the policy validations, RBACs, checks, and everything. Chaos Hub is our open source repository of all the publicly available faults that are available. The experiment is a blueprint, engine is the tunable. So it first pulls the experiment templates from the Chaos Hub, which is our public repository. It then tunes them via the Chaos Engine, CRD, and then it injects chaos. And once it does so, it stores it in the chaos result CRD. So these are the three primary components. you see there's something called the chaos runner pod and something called chaos jobs. What they essentially are, so our chaos injection is divided into multiple chunks. So the chaos operator is responsible for doing validation, checking if the application is present or not, if you have enough permissions to even execute chaos or not. And once it's ready, the way it does the chaos injection is it spins up a runner pod, which lives throughout the entire history of the chaos, and it spins up smaller chaos jobs that live for a small period of time. So they inject one chaos job, does the chaos injection, and dies. The next one spins up, it does the chaos, and dies. So that's how it works based on the interval we specify.
Okay, so we use the little mix chaos to enhance the con operator. So we need to design some chaos experiments. The first one, we think, when the operator's pod stop working, will it affect traffic processing? Yeah, it's important, and I think it's very useful. Yeah. So sometimes we think so. Another one is what happens when the operator experience continuous restarts. Yeah, this one is from our one real customer. Yeah, the customer finds in his cluster the operator pods continue restarts, and he wants to know what will happen. So we use this music chaos. The first one is a kill target container. Yeah, it can work similar this picture. Yeah, user input. We can use the user inputs to assign some variables. Yeah, and we can set about the con operator, and we can deploy our con operator and specific the container's name, and we can add some conditions. Then the litmus chaos can process these experiments, and it can kill the container, and we can see and we can use the probes to check the result to find what will happen. And another one is scaling replicates. Yeah, it's similar to the first one, and but it also uses the litmus chaos to scaling the replicas, and we can set new probes to check if the status, if we scale the replicas and the con operator, what will happen of the con operator, and what will happen in the con gateway instance, and we also add a new probe to check the application. We can check if the application can still return 200 status code to check the application is in normal status. Yeah. Okay. What's the next? We think we need to deploy litmus chaos, and we need to add more experiments and scenarios to cover all of the scenarios. What will happen to affect our gateway instance or affect our traffic process? And another one is we think we can run the chaos experiments continually, and we can check what's the value of the litmus chaos to help us. Yeah. Okay, that's all.
All right, that's all we had. You can find the respective websites here, and tomorrow we have a full talk on Litmus with the demo and all the architecture on 11 a.m. So yeah, if you want to learn more, you can attend that. So that's all from us. And we have a booth as well on P5 on the Solutions Showcase. So if you want to talk or discuss anything, feel free to jump by. Thanks.
Thank you.